Hello everybody and welcome back. Today we're going to continue our work with fractions, and yesterday I told you that you got a little bit of a preview of today's lesson, and so we're going to delve right in. We're going to be still working on showing equivalent fractions, and we're going to use our multiplication, and we're going to start shifting away from having to draw a visual model. We're going to recognize that we can just do some multiplying to find equivalent fractions without having to draw all these area models, which is really cool. So let's take a look at our first example here. We clearly have a rectangle in which 2/3 is shaded, right? If I want to find an equivalent fraction, remember we can draw some rows. We can split that fraction, those fractional pieces up into some smaller units. So I'm going to decide to break it up into 4 times as many units. So remember, if I'm going to break it up into 4 times as many units, I'm going to take my numerator and my denominator, remember numerator top, denominator bottom, and if I do 4 times as many of both, which is what I've shown here, whoops, sorry guys, if I do 4 times as many of both, I can find an equivalent fraction. So what I did is I made 4 rows, and I know that 3 times 4 for my denominator is 12, and sure enough, I have 12 sections, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've made 4 times as many pieces out of the same size rectangle. For the parts that are shaded, I had 2 parts shaded initially, and now I have 4 times as many parts shaded because I broke it up into 4 times as many pieces, so I have 8 parts shaded. So I've got 8/12 shaded. Notice that all I had to do was pick a number to multiply my numerator, the top number, and my denominator, the bottom number, by, and I could come up with an equivalent fraction. I didn't even need to necessarily draw it, though I want you to see what it looks like. Let's take a look at the next one. We can do the same thing. We've got 5/6 shaded. Again, if I want to take my fraction of 5/6 and let's say triple the number of smaller fractional parts I've made, I'm just going to make 3 rows, and now instead of having 6 total parts in my rectangle, I have 18 total parts. And I know that really quickly because I see I've made an array, a 3 by 6, and I know 3 times 6 is 18. So I know I've multiplied each part by 3. I've made 3 times as many pieces. Okay, so I know that I have 18 total parts, that's my denominator, and I have 3 times as many parts shaded, and 3 times 5 is 15. So my new numerator is 15. My equivalent fraction, therefore, is 15/18, right? Simply by drawing a couple of lines, or simply by saying, hey, if I make 3 times as many parts, I will have 3 times as many total parts and 3 times as many parts shaded, right? So let's take a look. What if we get something like this where it asks us to find if something is equivalent? Well, there's a couple of ways to go about it. First of all, you can model it in a area model. So if I draw my rectangle and I make 4ths, and I shade 3 of my 4ths, right? Then I can say, okay, but they want me to compare it to 8ths. So how would I break this up to make it into 8ths? Well, I'm going to do twice as many pieces, because if I have 4 pieces initially, twice as many of those are 8, right? So now I can check, do I have 6 shaded parts out of 8 total? I sure do. So I can draw the picture, but I can also think to myself, all right, I'm starting with 3/4. What do I have to multiply by to get 6 as a numerator and 8 as a denominator? So I can look across here and I can say, okay, 3 times what is 6? And I can say 4 times what is 8? Well, if I know 3 times 2 is 6, whoops, I meant to do that with my pen. 3 times 2 is 6 and 4 times 2 is 8. I know that I can multiply both parts by 2, have twice as many, and get an equivalent fraction. Well, what happens if I have a different equivalent fraction, or what we think is? Well, let's take a look. Let's model it. Here we go. We've got a rectangle. I'm going to make my 3/4. I'm going to shade my 3/4. So here's our first number on the left. We're going to keep that steady. Okay, 3/4. Now we're going to see if we can make it equal to 6/12. Okay, well, if I think of 3/4 and I ask myself, okay, what could I multiply 3 by and what can I multiply 4 by to get a 6 on my numerator and a 12 on my denominator? Let's start with let's start with our denominator. 4 times what is 12? Well, I know 4 times 3 is 12. So this is suggesting I need to make 3 times as many pieces, right? I have to triple it. So I'm going to make 3 rows. Now I do indeed have 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, I've got 12 total pieces. That's my denominator, right? I'm just going to take those off now that we've confirmed that. If I multiply my denominator by 3 and I make 3 times as many parts, I have to do, total, I have to do the same thing with how many are shaded. So let's see, how many parts are shaded? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That does not match, right? So how could I make this a true equation? Well, I would write times 3 and times 3, because if I'm going to triple the number of total parts, that's going to triple the number of shaded parts. So to make this number sentence true, I'd have to change my 6. Boy, I'm hitting all the wrong buttons, guys. I'm going to have to change my 6 to a 9 and show that 3/4 is equivalent to 9/12, not 6/12. So I'm going to write this is false. This is not true. But this is true. Here's how to make it true. So let's take a look. What if you're asked to just find an equivalent fraction? We have 3/5 without having to draw a model. Well, once again, you can take your original fraction and you can say, hey, I'm going to double the amount of parts. If you're going to do that, you're going to multiply both parts by 2, right? My numerator, 3 times 2, well, that'll be 6. My denominator, 5 times 2, that'll be 10. 6/10 is equal to 3/5. I can do the same thing and choose a different number to multiply by. So I could take my original fraction and say, well, I think I'd like to triple each part. Okay, so triple it. Multiply each part by 3. Looking across the numerator, 3 times 3 is 9. 5 times 3, and the denominator is 15. So 3/5 is equal to 6/10, and it's also equal to 9/15. And last example, just because it may look different, in this case we have a numerator that is larger than the denominator. That's okay. It doesn't change anything about finding an equivalent fraction. Still start with your original fraction, and if you want to quadruple the number of parts, then you'll just multiply your numerator and your denominator by 4. So looking at your numerator, 8 times 4 is 32. Looking at your denominator, 6 times 4 is 24. So you know now 32/24 is the same or equivalent to 8/6. So as you think about all these things, go ahead and do your activity, your problem set. You're going to be practicing writing equivalent fractions and using some multiplication, modeling some equivalent fractions, determining if some fractions are equivalent or not. If you would like to skip one problem, not one page, one problem, choose the problem you'd like to skip and write the word numerator there instead. Here's the word numerator. Write the word numerator on the problem that you would like to skip. That'll prove that you've watched my video. So with that, go ahead and give your equations and your equivalent fractions a try. Let me know if you need any help. Good luck and